Hello, welcome back. For this lecture, we are going to take a look at the examples that we discussed in this chapter. So the first example is about class creation, class definition, and the instance method implementation, and how to invoke the method, how to create an object, etc. So the first example is in the textbook. It's called Java class example 1, person class. So for this example, we have two files. A file called person.java. So this is for the class definition. So define the class. And we have the second file, two different Java file. So for this file, what we do is, so we write application on the class. Okay, so let's take a look. How do we do the work for define class and the test class? So in the person.java class, we define class, okay? So to define class, if you recall, in the previous two sections, we discussed the person class definition using UML diagram. Okay, and so for the UML diagram, it's just define the instance variable, and the method basically is just give instance method prototype. So just the method header part. Okay, so let's take a look about this class. So for the person class, we have 4 instance variable, if you recall, okay? So to define this class, we put it in a specific Java file, .java file. And for the class, we define this class as visibility as public, and then you have the keyword class, okay? So this is the first part of the class instance variables. So we have all of them defined as private, the visibility, okay? And we have the name, age, weight, and height, and we put an M to indicate their data members, okay, their member. And then the second, so that's the first part, okay? And then the second part, we start with constructor. And we start with default constructor, so they don't have parameters, okay? And if you take a look for the constructor, the accessibility is public, no return type. And the constructor's functionality, the purpose is to initialize instance variables with some values, okay? So here, all those are instance variables. So you just assign the respective default value. So you can define the default values, okay? And if you recall previously, we also discussed that the keyword this. So you can also use this data access, but we didn't provide that because we define this constructor inside this person class. And also over here, we directly access private instance variables. Okay, so this is allowed because even though they are private, but they can be accessed within the class. Because this is inside the class definition, so inside the class, okay? And so the encapsulation, even though we have the encapsulation um, um, features for object-oriented programming, but because this is inside the class, so it is allowed us to directly access. And for this person, this is also constructor. But this constructor has parameter list. Okay, so this we call it explicit value constructor, but always remember constructor doesn't have return type. So when you have parameter for constructor, what you do is you assign the parameter values to the instance variables. That's what we do, okay? So basically here, you also initialize the instance variable with the values that you provide through parameters. And next, we have the group of accessors. So all these are get methods. So they are called accessors. Okay, accessors, if you recall previously we defined, they don't modify. No modification. So not modify instance variable. Okay, but they retrieve their values. To retrieve, they have the return and the corresponding data type. So they have the return statement, return statement, return statement. Okay, but previously, for over here, if you take a look at the name instance variable, its type is string, and we already discussed string is immutable. So even though it is object, okay, but so that's why we have that get name method is it just return it, and the outside can basically access the name. Then suppose if it's regular, if it's mutable object, if it's mutable, then they can also modify it. But because it's immutable, so that's why it's fine. But if we change this to char, to array, okay, and when you have that get name, what you return will be an array. And return an array, then it will be the shallow copy or aliens. So it will be the M name, is it, when you return. So you return the same memory location. Then basically external can get can access the instance variable. So then, but what you we expect the MNAME is private, so it's protected. Not oh, suppose not to be able to be modified by outside. But if you return array, then it can be modified by outside. So the private accessibility and visibility then doesn't function correctly. So this then is going to violate the encapsulation rule. Okay, so then in that case, that can cause the aliasing problem. So attacker can take advantage of this, do some attacking, okay, malicious operations. So we do really need to be careful about this. So the above are about the accessors. So next we have a set of mutators, okay, or the set method. Normally we have the set word in the method, okay. So what it does is you assign the parameter to the instance variable. But before you go ahead, do the assignment, do some check, okay. If it's null, or like in this case for string, or if it's doesn't have anything, is it? Then you do. Otherwise, you need to prompt the user to assign some correct ones. So in this case, because this MNAME is string is immutable, so it's fine. You do direct assign, okay. But if it is if it's a char type, char array, then it's going to be an issue, okay. May have security issue. So we needed to be careful, okay, about it. So if it is mutable object, so instance variable, if it's mutable object, then we need to be careful. Otherwise, attacker can take advantage, okay, and do something through the mutator. So same thing for set age because it's a primitive type. So there is no worry about that, but just need to make sure the age needed to make some sense. And same thing for the weight and for the height. Just need to make sure the value you try to pass in are the valid, the sensible values. Okay. And sometimes you can also provide a method that's going to not just just modify a single instance variable. You can modify a group of the instance variables. So in this case, this is kind of also like the explicit value constructor. Okay. And sometimes people provide like a set the object method, and then constructor just go ahead and call this method. Okay. I normally prefer you also do pre-check, pre-condition check, we also call it, to make sure all of those argument values are legitimate, legal values. Okay. And here is show you can also use this to access in instance variables. Because why we do this, if you take a look, the parameter name is the same as the instance variable. So if parameter name is the same as instance variable, then better to have this to differentiate which one is parameter and which one is instance variable. And if we take a look, you can also do using the get self. Then what you return? Return the object itself, okay? And the type is a person. So this is the return object itself. And here we return the clone of the person. If you take a look, so this is object itself, okay? And over here it's you have this clone person variable, but you do this new. Okay, when we do new, it will create memory on heap. And the heap memory going to hold this object. Okay, so this is a clone. But you can see it's exactly the same with the object itself. Is it? So it use object itself's instance variables variables values. Okay, but be careful also here, same thing. It's because in this case, the instance variable are either immutable object or primitive. So that's fine, okay? And if your instance variable contain mutable objects, then when we do the get clone, we need to be careful because if you directly pass the object itself's instance variable, basically it's a shallow copy, okay? So in that case, you better to have a clone or the object's clone method to create a deep copy so that you can have a real deep copy of the object instead of some parts of the object still shallow copy from another object. Because that can also cause the security problems. So have a security hole, okay, so that attackers can go ahead to take advantage of that. And then we over here have this uh, some kind of like tailored method for the class. Okay, so this is just people talk. Okay, so just mention the name and some message. Okay, and here for the toString method, if you take a look, we have this annotation called override. Why we do this is because this toString is from superclass. Basically, it's a root class object. And so we needed to provide our own version of implementation. So this is a definition for override. So your own version of implementation. Okay, so override a method means the function name are the same. So over here we call it method name. and return type and parameter, okay, are the same. The same, okay. And so this is called override to, generally speaking, it's from the superclass, from parent class, okay. You provide exact, but the implementation is different, okay. So in this case, you can see it's just a return, basically the string version of the information, okay, name, age, weight, and height. And we also have this tailored method, like introduce yourself. Okay, over here you see, we call that toString method that we override from the object class. But here we want to use the object itself, so the persons, okay. And next, let's see the equals method, okay. So the type of the parameter is object, and here same thing, we have this annotation called override. That's because this also inherit from object class. Okay, so that's why we need to override. So the same return type, same name, and same parameter type, but the implementation is different, okay? And previously in our previous session, we already discussed about this implementation. Okay, so that's the person class definition. Next, let's take a look at the implementation of the application part, so the testing part, okay. So the testing part in a different Java file, and generally you also have a class for your application, and all application we write is in the main method, and the main method has the status, so it's a class method, okay. And if you take a look, the very first thing is P1, the type is the person, okay? And you do need to have new, okay? So for object, you do need to have new to create the object so that the block of the memory from heap can be allocated to this object. And so basically, P1 is just a variable name on stack that's going to point to the block of memory on heap. And then you can output. And here, why you can directly do print line P1, that's because inherently it will call that P1 dot to string, basically. It's just this part is skipped, okay? So implicitly, okay, it will be invoked. And we can also to call the, you see, each person's name and age, height and weight, is it, using dot. And before that is the object. So P1, we call it an object or an instance or person class. Okay, so you do need to keep this in mind, you just like array, okay, whenever you try to use it. Okay, next, we try to do some modifications. So we already test the accessors. Next, we try to test all the mutators. Okay, So over here, we will from keyboard, so using scanner from standard input, so keyboard, to get the name, okay, and then also get the age, weight, and height. So once we got this, then we can call all of the set method to basically over here is we modify P1, okay. And after that, we can check if it does modify, as we will see. And then we also check the set person method with a different set of values. And then we can see if P1 get changed. And we can take a quick look of the running result. I already ran it so that to save us our time, okay. So if you take a look, yeah, it initially with the constructor without a parameter, its name is default. Okay, here's the age weight. And then we call that to string, is it to output. After that, we change the name, okay, and we also reset the age, weight, and height using these two set two line of input values. Then did you see after we call them all are changed, modified? Then we call the set person method. And you can see the name and of the value changed again. Okay, let's move back to the code. Next, let's see. Okay, we create another person called Jane and has a name and everything, is it? And here we call that a get clone method. If you recall, the get clone is create the deep copy. This is deep copy of Jane. Is it? And also we have this Jane alias. So that's it's get self, is it? So that's object itself, this. Okay. Then you see we changing Jane clone's age. Okay, and then we test Jane clone's age, and then we can also check if alien's name changed. Suppose not, is it? So it shouldn't be changed because the age change is on the deep copy, not on Jane itself. Okay, and then we change the alien's age to 12. Is it? And then we can check if clone's age change. It shouldn't. Shouldn't. Okay, because it's a deep copy. Okay, but we can see, we can check if Jane's age changed. Yeah, it did change. Because aliens and Jane basically is the same copy. Is it the same object? It's just two different names. And we can take a look at the running result to verify if our the guessing is correct. Let's see. Okay, then here it is shown. So this is clone, age is 11, is it? And alias age is 10, original age is 10, okay. Then we change alias, is it? You see, the clone does change, follow the alias, but clone not changed. Okay, next, let's see the new set of operations. Okay, then we created two new person, Bob and Clary. Okay, and then we have Bob and Clary talk to each other. Okay, so just invoke the talk method. And we can also let Bob introduce himself. And what next we did is we check the structural and referential equality. Is it so? Jane and Jane Crow, structural equality, yes. Is it? And Jane and Jane alien structure, yes. Okay, because all the contents are the same. And is Jane and Jane clone referential? It's no. And Jane and the aliens, it's yes. Okay. And then, oh, here, no, it's not just Jing and Jing clone should equal to yes. It's not yes. Because if you recall, Jing and clone's age so already changed. Changes, so no, okay. Yeah, we needed to be careful. But this aliens and Jing are always structurally equal, okay. And then we set aliens check. We change the aliens check. Is it? And check aliens, so this will be the same. Is it? And the Jane and Jane aliens structurally equal? Yes. Okay, because if referential and then definitely the context. Okay. Uh, will these two? No. Is it? And will Jane and Jane Clo be the same? No. But you see, if you said gene clone the age also to 101, so aliens and the gene clone both 101, then the clone and gene, yeah, this is yes, because aliens is gene. Okay, so just be careful about this subtle difference. So that's why here you can also see is that if you have the aliens, if we are not careful, then through aliens, basically you can modify the original. So that's also have a security, may have the security hole here. Okay. And what the next one we do is we create the person using explicit constructor. Okay, and then you can also call the name and get of the information called the respective, like set name and introduce yourselves. Okay, and over here you can check if P2 the get cell because it's a return so basically object yeah this is yes. Okay, and the get clone no because it's a different object that's not P2 itself. And what next we test is the get name, get age, and then we also test the uh, structural equality check. Quality check. Yeah. So P2 and the clone definitely equality, is it? And the clone, yes. So both are yes. Okay. Okay, and then next, let's take a look two method. Okay, and very interesting. Okay, and also we need to be careful. So these two method, one is called a swap person copy. Okay, so the parameter is two parameter, both are type person, and here are the parameter name. Okay, and if you recall, generally when you do swap, you think it's supposed to work, is it? Supposed to work. But let's see if it will work. So will it work? Suppose, is it? But will it work here? Yeah, the answer is no. Okay, and we will see. So if you do want to use the regular swap method using like a temp, how do we do it? Is it so there is a way to do it is you do the pass parameter as array, then it will work. So you see the difference between these two, okay? Then if you do the second way, then it will work. So let's see, what do we do here? Okay, so here we have person one and person two, is it? And we call the swap and then see if we changed. And the person two, we just created. Person two, what is person two's name? Oh, person two is called Peter. As Peter, yeah. And the person one is already involved multiple versions, so we will see. Okay, and for the second one, the second version, swap person, here we have two array, but just one element array. Okay, then we assign P1, P2 to both array, and then we pass in the array. Then we check if they got swapped. So we can take a look at the running result. So here is output of the first swap method. If you take a look, yeah, P2 is still Peter, okay, and P1 is XYZ, so not swapped, not swapped. But for the second version, if we take a look, you see it got swapped. Okay, so it swapped. So that's interesting, I think. And over here, we also write a very simple method to pass by value as a primitive type. And you want to change it to negative. Will it be changed? We can test it. You can see it's not got changed. So it didn't work, okay? Okay, then we check again, is it? So this time we have check path object, is it? And you just call the method set method, is it? So will it change? Is it? So the second case, because over here you check P, you work on the parameter, okay? And let's take a look what we call in main for check object, check path object. Yeah, check path object, we pass P2, is it? P2 is Peter, okay? And we will see if it's getting. what we did is P2 is passed. Okay, so supposed to P2 data set person, is it? So let's see. Did Peter get changed? Yeah, you see Peter name did get changed. Okay. And it has the new age, weight, and height. Okay. And then let's see. And what we do is a little bit different. Okay, so the parameter is passed, and here we create a new object, is it called actor, okay, and with the age. And then we assign P to this new object. So do you think like P2 will change? So we will see basically P2 will not change. Well, let's see the result. You see P2 not changed because if it's changed, it's supposed to change the name to actor. Yeah. So why this not change? Why this is changed? Okay. So if you recall, in Java, all parameter is passed by value. Okay, for primitive, it's just a copy of the values. Okay, for reference, it's the reference copy. Okay, reference copy. So over here in this case is, so this is a heap memory. So that's the Peter. Okay, so P2.2 Peter. Okay, and when you call the check pass object, is it? And so P is a copy. P is a copy of P2, so it's also pointed to P2 basically. So it's a shallow copy. So that's why when you do the set person, it's set on Peter. Okay. But for this case, P initially pointed to here, but then you have temp. Temp is here. And then basically what you do is P2, or P doesn't point to P2 anymore, doesn't point to Peter anymore, it points to temp. That's why the actor is here, it's not on Peter. So that's why original Peter not got modified. Okay, so we needed to be really careful about all of this. Okay. Okay, so that's the discussion about the first example in this chapter. So let's just stop here for this class.